We are going to solve an inequation involving absolute value. So here are the two situations we will explore. So funding, suppose that I have a quantity up to capital X with absolute value less than A. So where can I find, where are all possible quantities that will satisfy this inequality? So here it is. The answer is that a capital X should be between you. We should consider all those possibilities. Okay. The other situation is um, what if we have greater than, for example, or greater strictly, okay, of from A. Okay, then here, so here let's at the same, so or let's say the answer, then explain why. So the possibilities is that X remain less than minus A, or X remain greater than A. Okay, so let's visualize this using a line here. Okay. So if you look at your line here, and we, of course, here we assume that our constant A is positive, okay, strictly. So here it is 0 and A is here. So we are looking for all possible quantities X that with their distance from the origin remain less than strictly from A. So I can see that all the values between 0 and A will respond to this are, yes, because the distance from any point to 0 here will be less than the distance, total distance A. But the other points that are located in this, the other side of the remaining greater than minus A, will have also a distance that is less than A, because here also the distance is equal A. Okay, so all possible the values, yes, possible values that we can include are the values between minus A and A. Okay, we cannot take consider an X here because a distance then will be greater than the number A. If we choose an X here, it will be also greater than the distance A, the number A. If we take it at minus A, it will be exactly equal A, but we want strictly, we are excluding the equality, so we cannot include minus A and A. Okay. For the other situation, so this is the interval. Yes, the possible values, we said minus A and A, we are here. Okay, so we get this part. You are excluding the two this endpoints. Similarly, if you consider, if you want to consider the other inequality, for the other inequality also, if you have the origin here and you have your A here, and you are looking for all possible x's that are have a distance greater than this distance A, then your x must be in this side. We want it also possible to A equal to A, so we will include, so let's put it like that, more a bracket like that, distance to show that we are including A. And we can also consider the values less than minus A, because then the distance to the origin will be greater than A. And since we are including the possibility of equality, so we will include A also and consider all these possible values. Okay, so this is x less than minus A and x greater than A. Okay? So this is how we solve an equation of this kind. Okay. Okay. So let's now practice. Okay, there's two there's two inequations. And so the first example is the following. So suppose that you are given to solve an equation of this kind: 3x plus 4 plus 5 less than strictly than 1. So it seems I can bring myself to the first situation. Let's do eliminate the constant. Okay. So if I eliminate the constant, I will get so 3x plus 4 absolute value less than 1 minus 5, which is minus 4. But then I have something positive, strictly less than minus 4, impossible. Okay, we cannot have, so there is no solution. So no solution. Sometimes we denote also as the set of solution is an empty set. Okay, let's do another example. What we were given minus 3x absolute value greater than 4. So this one seems in this with the second type in this. Okay. So yes, I take it. I take the expression minus 3x like quantity, capital X. So I have these two possibilities. Either minus 3x is less than or equal minus 4, or minus 3x is greater than 4. Okay. And here, so next step, I have an inequality, but so I need to isolate x. So this factor I can multiply by its inverse or divide both sides by minus 3. But because minus 3 is negative, so I need to be careful and change my inequality to greater to equal minus 4 over minus 3. Or so, or similarly here, x will be then less than or equal 4 over minus 3, which is minus 3, like that. I can here write it, it's just 4 over 3. So you see, you have, yes, you in terms of intervals, it, you can write it. It's good also use to use the line. It helps to visualize your set of solutions. Okay, so set these limits. There's minus 4 over 3 and 4 over 3. So I want values less than or equal, so including minus 4, and below, then greater than. Okay, and then your set of solution, you can write it then as minus infinity, minus 4 over 3 using a notation interval, union sets, we are dealing with sets, okay, or 4 over 3 plus infinity, and open at minus infinity, infinity. So this is how we deal with inequations like that. Let's do one more. So suppose that you have 11 minus 6 times absolute value 3x minus 8 greater than 5. So here also, so as I think I can bring myself to one of them if I can eliminate these constants. So let's move the, yes, let's isolate the expression in x. So I will have minus 6 3x minus 8, absolute value greater than 5 minus 11. Here it's minus 6. So I want to divide by minus 6 both inequalities. So I need to be careful because I have an inequality, so I need to be careful. So it will be, I need to change the unequal signs of the inequality will be then 5. So minus 6 we said. Okay, minus 6 over minus 6 over minus 6, which is 1. So I now, which is 1, this one is 1, okay? So I am then in the first situation. So the answer, the possibilities are given by 3x minus 8 between 1 and the opposite, okay? Again, now inequality first degree, I need just to eliminate then First, regroup the constants. So add both sides of the inequality, the quantity 8. So let's continue here. So I will have 3x. If I need to eliminate minus 8, so I will add 8 both sides. So minus 8 plus 8 less than 1 plus 8 greater than minus 1 plus 8. Okay, so I will have 3x between 7 and 9. And then now I need to divide by 3 both sides. So I will 3 is positive, so no problem. I will not change. I don't have to change my inequality. Okay, so let's now graphically illustrate your interval possibilities. Okay, so you have 7 over 3 and 3. Okay, you are including, so you are including those endpoints and the values between them. So you can write here the set of your solution as the interval, closed interval 7 over 3, 3 for your equation.